Good morning, doctor, and everyone watching this video. I'm Brandon Chan and Hao from section 2, and today I will be presenting on question 2, 4, and 6. This program is for question 2. So the first line of the program is to move x val into EAX. Then the next line is to negate the value of EAX. Then the third line is to move y val into EDX. Then the fourth line is to subtract EDX with z val. Then the fifth line is to add EAX by EDX. Then line 6 is to increase the value of EAX by 1. Then lastly is to move the value obtained of EAX to move it into R val. Then that's all for question 2. And I'll be moving on to question 4. Moving on to question 4. So the first line is to move var 1 into AX. Then the next line is to move 5 into BX. Then the third line is to multiply AX by BX. Then the fourth line is to move var 2 into BX. Then fifth line is to subtract BX by 3. Then the sixth line is to divide AX by BX. Lastly, storing the value of AX into var 4. Then that's all for question 4, and now I'll be moving on to question 6. Is the full program code for question 6. So the first line is to move 0 into dx, ensuring that the value is 0. Then next is to move 803 in hexadecimal into AX. Then is to move 10 in hexadecimal into DL. Then is to divide AX by DL. When dividing, the quotient will be stored in AL while the remainder is in AH. So in order to ensure that DL is storing the value for the remainder, so we move AH into DL. Next, in order to ensure that the value of DX is for remainder, we move 0 into the high register of D. Then we also move 0 into the high register for A. The dump racks as required. So as you can see, EAX is the value of AX is 0080H, while the value of DX is 0003H, which as required, storing the value for quotient inside AX and the value of remainder inside DX. So that's all for my presentation for lab 2 for question 2, 4, and 6. Thank you for watching this video.